Hello, welcome to another Hydra intermediate tutorial. I think this is the fourth video. And in the previous videos, we explored feedback and layering, and we did feedback again, combining this knowledge from layering. And we did some kind of like interesting patterns with webcams and also like geometric patterns and so on. And in this video, I want to explore Fractal because there was a request in the previous videos. And I think it's a perfect moment to introduce Fractal because we can make use of layering and feedback. Just before we jump into coding, I want to open the Wikipedia page on Fractal just so that we know what we're talking about, and I will shrink myself. Okay, so we can read it. So basically it's something from mathematics and it's a geometric shape containing detailed structure at arbitrary small scales, usually having a fractal dimension strictly exceeding the topological dimension. Oh, that sounds like something. But basically what, like in a nutshell, like, well, I'm not a mathematician, so if I'm saying something wrong, well, please do your research. But basically my understanding is that in this GIF, for example, you can see that it's like starting to magnify the pattern, and it's the same pattern. I mean, okay, it's like rendered, so it's not like something that exists in real life, right? It's actually exceeding topological dimension. That's the whole point. So if you like magnify, like, microscope or something you can imagine, but this is, but it's like just produced digitally, I guess. And you start to see like the same structure like recurring again and again and again. So in this case, it's like these like squares, and you see like squares inside the rest of the space, and then another square, another square, another square. Another one like Mandelbrot is also very popular one, and with this as well, that you magnify it, you start to see like different structure happening in different scales. So it's not just like, we have this square, but there's like a square inside a square, inside a square, inside a square. This kind of thing is fractal. This is my interpretation. Also, like I recommend, for example, like Coding Train from Dan Schiffman on processing and P5.js. That's really nice. They have really nice examples on fractal, so that could be also interesting, like comparison. Like I know this is like Hydra tutorial, but comparing these like different tools, we're gonna actually talk a little bit about it, how it's different from how you would do in processing P5.js. But let's see. And something is that like we cannot make a real fractal. I mean, we cannot never make it on the computer because we are limited by the pixels, and especially in Hydra we have, it's not like vector images or so that we are like limited by pixels. We're painting literally like pixels. So if you start like we cannot do something like this, because if you start to magnify, I mean, this is just an example from the Hydra editor, but from the community. But if you start to like magnify, you will just start to see pixels, so you will not see like recurring patterns. But the thing is that if we see this image, I want to make something that looks like, okay, there's like small structure happening inside the structure, another structure, from without magnifying into the whole image. So let's start with like small recap of the last videos, and I always like to start with simple code like shape or OSC. Today I think I'm going to use shape because I want to have shape inside the shape, inside the shape, inside the shape. That's the first goal. And we'll just do simple feedback, and I like to like make it like build up gradually so that I know that I don't make like syntax error and so on. So something like this, and probably already that this doesn't, well, this is doing feedback technically, but it's not like visible because we are overlaying something that is, well, first of all, something that is opaque, so we have to make it transparent, some part transparent, and also this will still not work because we're just like slapping the same image on top of the same image. So we have to do something onto like this source 0. For example, what we saw was like scroll X. And I will do something today which I said you shouldn't do in the previous video. And also like just like a little disclaimer that if you're photosensitive, I would like I would say like don't follow this. It might make like a flickering effect. So if you are photosensitive, just be careful. And also like I think what would really help is to say like FPS 1, for example. That changes the refresh rate of Hydra, and FPS 1 means that it will refresh once a second, so it will become like kind of the image will be like very choppy. That will not make it not flickering, and I think the default value is like 60, so it's like updating 60 times a second. That's why it makes it like sometimes like very flickery effect. But for now, I will stick to the FPS 60, and I'll try not to make crazy images at the moment. But just so you know that with the feedback, it's easy to make like quite wild visual effects. Okay, so last videos, like I said, okay, like start with something small. So scroll X like 0 doesn't change anything. Well, let's see, doesn't change anything. So I would say like 0.01, like small value. And what happens is that this is kind of interesting. So it's like scrolling a little bit and slapping a new image on and on and on. And source 0, which is what is rendered onto, that's why it's making feedback. And it's like gradually moving. So you see that this pattern like shifting all the way, and it's scroll X wraps around, so you see that it goes all the way and it comes back in. This is not fractal. It's just a repeating. Well, it's repeating in a way that it's, how do I say? It's repeating in a sense that it's not fractal. Maybe it's fractal. I don't know. Well, it's not, because you zoom in and still you see the same. I mean, you don't see like mini structure happening again and again. So I said zooming in, so I think it's something has to be with scaling. So I would say like scale. And as I said in the past videos, like scale, like if we want to stick to small number, scale 1 changes nothing. So we have to like move from there. But with fractals, it doesn't necessarily have to be small number. So I'm contradicting myself. I'm sorry. So basically, if you want, something like this pattern, you see that actually the idea is that this square, there's like mini square in there, mini square. And if you think about the ratio of these squares, it's like 1 to 3 or something. I think there's like a static version here, this one. So there's like this big square here, and well, in this one it's black and white, it's flipped from what we're working on. But basically this mini square is like a third of the original square, and there's like a third of a third, so it's like 1/9, and then 1/, I don't know, 27, or like, so it's like kind of like multiplying a third every time. So we just actually have to do this. That's pretty much it. And let's see what's going to happen. Yeah, let's just do it. I'm hesitating because I have a few things to say, but let's see what's going to happen. So, okay, this is way too fast. And now the whole image is like kind of white-ish. And the problematic thing is like, okay, I want to go back to what we had, scroll X. We do this, but then it's not, okay, now it's going a little bit crazy. So I will, maybe just leave it like this. It's moving. The problem here is that as we do feedback, we're actually not refreshing the whole canvas. We're just doing something on top of it, on top of it, on top of it. So now like we're not seeing the same thing as before. We see this weird thing in the background going in circle because we did the scaling and then we did the scroll X again, and we're not refreshing the canvas. So if we really want to like clear the canvas, we can even do either do this trash can button, but then it will clear the code as well. So what I normally do is to do solid out, just to keep this code on the side and just do solid 0, 0, 0, which means black. And if you want to be explicit, we can put 1 or 0, whichever. Like it's about transparency. Well, it's about transparency. Well, for the transparency, I explained. This will make it transparent, and you see but the browser cannot be transparent, so there's like a backdrop. We're seeing the backdrop, which I explained in the past video, or you just paint it black. Either way, I mean, it doesn't really change in this case. So to have a shorthand, I just do it like this, and I keep this code on the side. I evaluate it with Control Enter, and if I want to go back to this, I evaluate this part. Also, I move the cursor here and use Alt Enter or Option Enter on Mac. This will evaluate the chunk of the code. So now you run the code and you don't see this thing in the background anymore because we wiped it with this. So this is kind of like a little trick when you're like working on feedback. So now what I'm going to do is I'm going to put the scale, well, now because the screen's blank, I can do the scale again, and I said 1/3. Let's evaluate it. So it's doing something. It feels like we're getting there, but because we see these like ghosty triangles everywhere, which is coming from the border. That shape default parameter is 3, then 0.3, which is the size of the shape. And then you can set the kind of, the border. And if you make it like no like transition from white to black, which is 0, and then what happens is that, well, you still see like all these little weird dots if you are running. I mean, it depends maybe on your resolution and so on. But on my screen, I see like little dots, but it's basically filling the whole space, because the difference between what I'm doing here and what is rendered in, for example, this Wikipedia page is that actually, I think they say it. Yes, they say that it's to the level 6, which is they're stopping the iteration at some point, because if they start like continuing the iteration again and again and again and again, well, in this case, its color is flipped, so it's going to be probably like completely black. Now, in our case, it's completely white because it's doing the iteration more and more and more and more, and it's just like trying to fill the whole space. What I mean is that now actually I can come back to this FPS parameter. So let's clear the screen and let's run this run it with FPS equals 1. What happens here is you can see that there's one triangle, more triangles, more triangles, more triangles. So it's doing it. Okay, so here if we have a snapshot like after like 5 or 6 iterations, it looks quite nice, but then it just goes on and on and on, because that's very like different thing from how you do like recursion, for example, to make fractal in processing P5.js, where you can like set like the level of the fractal or the recursion, like how many patterns you want to see like inside, you can have pattern inside the pattern inside the pattern, but you can stop it easily in processing or P5.js when you code it in that way. But in Hydra, it's not straightforward to do it unless like you have this FPS 1 and then run it again. Okay, I have to do the solid first and then run it again. And then you can see for a few seconds, like a nice pattern. Okay, this was nice. But you cannot really stop it because that's the nature of feedback that goes from out 0 to another out O0 through the source O0. It just like iterates. We cannot really like easily have a condition. I mean, we can like code something to make it happen, but it's not really straightforward. And I try to think like what would be like a creative solution to it. And one way to do it is to make it really crazy inline coding things. Well, okay, so that's not the creative solution. I would say like one way is to make some colors. So let's go back to FPS 60, and I'm gonna just delete this line for now. So let's do something. Here I'm doing shape. Oh, did I say R? Actually, this is something maybe new to you. I'm sorry, didn't really explain. Basically, it's a shorthand for. It's the same as like doing Luma, I think. In this case, but I like to use R sometimes because it's basically taking the red channel of this shape and replacing green, blue, alpha channel with the red channel. So it's effectively like using the, I mean, it can be like G or it can be B, like taking red or green or blue channel and just use all the channels, the same value for all channels. So the alpha, which is opaque in original shape, it becomes the same color or same value as red, or it can be green or blue. So I like this kind of shorthand because, I mean, in this case, it's doing the same thing. In other cases, it's not the same. But because Luma is doing some kind of like thresholding, and sometimes you want it, sometimes you don't want. But maybe I can just keep it to Luma for now. And what I'm going to do here is I want to color it. And the first color I come up with is red. So I do 1, 0, 0. And if I just run it like this, then it's going to be the same thing, that it's going to be wiped with red. Let's do it. So it's the same thing. But the difference we can make is by changing the color every frame. And remember, like I said, okay, like let's use hue. I start with like very small number in the previous video, which we could do also, which is like okay, but then we could be actually a little bit more like wild with this choice. So for example, well, it made like, you know, kind of flickering effect at first, but it kind of like converged here, which is nice. Why is it? It's like, I think it's like connected to the scale and hue at the same time. So if you do, yeah, because the scale is kind of more like drastic in this case, not like 0.999 or 1.001. So if you make big hue change, it's still okay. Well, it doesn't really explain. But I just use it as a pattern like this. And now you can see that it's like repeating, and it's great. I might also change the shape size a little bit because, well, let's try to make something, like recreate something that is look like this. So that's a square. And I think the center square, it's a third of the screen. So I can stick to 1/3. Yeah, it's the same. Like basically now the color is different, but you see the structure is the same as the one we saw in Wikipedia, which is great. And again, what I wanted to like kind of express in the beginning of the video is that we made like nice pattern, but you can't really zoom in because you start to see these pixels, which is kind of cute actually. But yeah, because of how it's like drawn, like you can make the resolution super high, but you still hit the same like problem that if you just start like zoom in, you will see pixels, because that's how we work with like textures like this. So let's make some variations with this. So this is quite nice, I like it. So that's an achievement. And again, like I said about this R function, instead of Luma, it will do the same thing. In this case, I can just clear it and then run it again. Yeah, so either way, it works for you. Whichever you like, just try it. And okay, so another one, like I think what we see quite often is this like triangle, but not, let's say, like I'm over with this, so, or maybe I just keep it as a pattern. So I mean pattern in like coding pattern. So instead of like this shape, what I want to do is like I want to have kind of triangle with like right angle. So this is like supposedly, I mean, if we have a square window, it will look like all the sides should be the same length. What I mean is scale just for demonstration. These like shape functions, well, shape function would make something like this. Yeah, if you squish it, it looks like all these three sides should have the same length, which is quite nice because if you do shape 5, shape 6, you see like these nice patterns, right? Or nice shapes. But normally I work with this stretched window, so it feels a little bit funny, maybe a little bit cute. But what I wanted to make is a triangle that is, how is it, like two sides have the same length and with the right angle. And to make it, I don't know if I did shape 1 before. Maybe I did shape 2. So what is shape 2? It's impossible shape, but it's easy to make a line with this. And another one I discovered like really handy is shape 1, which is another impossible shape, but this basically fills like half of the space of the screen and dividing with horizontal line. It's kind of like, you can imagine like making flags would be easy with this pattern, with this shape. And the funny thing with this shape 1 is the only one that is like, if you give 0, like if you give 0 to like shape 2, okay, maybe you see a little bit of line, but like almost non-existent. Shape 3, it doesn't exist. But shape 1 with 0, funnily, it covers exactly half of the space. And with this, if you do rotate, for example, we want to use math pi. For example, if it's math pi divided by 2, which is like 90 degrees, then it will cover like vertically, like split into 2 pieces. And if you do math pi divided by 4, it will make this nice triangle. And I'm going to use this one for the recursion or fractal or whatever. I'm going to just like copy the same structure as I did above. Even the hue, I will do the same because, well, you can just copy and paste, of course, but sometimes it's nice to, it's relaxing to copy the code by hand. Something like this. Yeah, so there you go. You can have recursion pattern with this triangle, and I think it's also like kind of common pattern or like that you see in like fractal example. And you can go a bit wild with the hue value, or if you want to have like different color for the initial big triangle, that's also possible. You can really like experiment with this. And what if you use your webcam for the instead of the color? That's also possible. Should I try it? I guess I have a lot of time to do experiments, so init cam, and I'm gonna allow the camera. All right, so how can we do this? I guess the easiest way is to use something inside the layer. Now this time, instead of shape, I will do source S0. And so there are like different ways to work with alpha, which we explored with Luma, with mask, and today I used R function as well. In this case, I will do like mask, because now we're gonna be like using this triangle shape to cut out the S0, so something like this. So instead of using the luma of this function, we're going to put this as a mask of S0. And there you go. And I don't even have to change the hue because now I have like color variation within this triangle. So I take this hue out and you can still see that it's, well, this is not really video, well, camera friendly pattern. You see like aliasing, which is not recommended for TV and stuff, but on the screen it looks quite funny. And I kind of, my face is like gone, which is really nice. So yeah, there you go. We explored fractals, and also like you can do some funny things like, what if you do like rotate inside here? Math.pi divided by 2, like flip it. Yeah, well, maybe it's not really working, but okay, maybe this is not working. But anyways, or you want to do, if you want to do colorama, you can try it as well. Yeah, just like how it was like with hue. So there are like a lot of things you can experiment, and also you can do this same thing with this example here, right? So let's try that. I'll take the colorama out. So basically the idea is like fairly simple. You just take this shape that I want to use as a mask of this webcam image. So shape 4, which means that it's a square, and then the size of the square should be 1/3 of the length of the screen, and no border. Let's see what it does. So my face is there. My face is repeating and repeating and repeating. If you want to fit the whole webcam in this frame, like instead of like zoom, like, because now it's like zooming into my face, how do you do it? How do you make your screen fit into, or the camera image fit into this, and then repeat, repeat, repeat? Maybe you can pause and try it out. And I'll just give you an answer. I hope that you paused it and tried it out. The way I would approach, I mean, actually there are like 2 different ways to do it. One is to do scale, and you do scale. So this is actually quite tricky because you want to do scale here instead of after masking, because if you scale it after masking, I can also try. And basically I want to shrink the image by 1/3, but if you do it after scaling, then this whole box becomes smaller, so that's not what I wanted. Instead, I want to shrink the image first and then take a mask, so the mask size doesn't change. Yeah, there you go. So the whole frame is now in there, and it's like repeating and repeating and repeating. Also, you can do actually, like in this case, we can do the same, we can achieve the same visual effect by repeat, and repeat 3, 3. So it's like tiling 3 by 3 images, but we're like cutting off the mask here. It does the same, so it doesn't really change anything visually, but you see that it's both ways work. I think scale would be more intuitive, but you can explore with this. And also like what it's important that you did scaling here instead of mask after the mask. So if you want to have some kind of like rotation, that's also possible, but just make sure that you do it here. I don't know, I can also move it, right, in time. So now my image is moving, but not the mask. If I put the rotate after mask, then this whole box is rotating, which is also actually quite interesting. I'm gonna stop it because it's quite distracting. So yeah, this was a quick tutorial to Fractal, and I hope this inspired you to do something more. Yeah, and I think it's quite interesting to see the difference between how you make Fractal with Hydra versus how you would do it in P5.js or processing, because again, like you don't have this, you cannot easily limit like how many iterations you want with this code, because it just goes on and on and on, and it's really hard to do it, how to limit it. You can use FPS just like I did, but that will not stop. It will just delay the effect. And also, if it doesn't really work in this like webcam example, because if I do like FPS 1, then I am also becoming choppy. So you can see that this progression really well. It's actually quite interesting how it works. But sadly, myself is also very choppy because the whole frame per second is limited by 1 frame per second. Just put it back to 60. And yeah, there are other ways to like approach this, I think, like for example, making some kind of like clear the whole thing. So I did like solid 000 out like manually and then run the code to make this fractal again. But for example, like you can make another layer. Maybe this is a little bit more like advanced, but you can have many layers. And for example, if I would do, I like to use like OSC with like 1 and 1. So it's really like, so what it looks like is always like just try it, something like this. And I like to use this as a mask to kind of wipe everything out, which is like work, like not just for Fractal, but it's useful for feedback as well, and to make some kind of like variation. I like variations. And I do like threshold, and in this case I want to threshold it quite at how do I say, like big value and no border. So what happens is like once in a while this white thing comes in, but it's not like same rate. It comes in like very much like once in a while. And again, I want to work with transparency, so I will do luma, or you can do R function as well. And this will like completely wipe the screen with this white color. So let's try what it does with this combination. So I have this fractal, well, let's say fractal, and then this whole thing is wiped out. If you don't like this kind of transition, you can also, like this horizontal transition, you can also do dot pixelate 1 1. Well, let's see how it looks like just as it is. So this was the original one, right? And then I would do like, actually pixelate can be anywhere in the code. Pixelate 1 1, it's a pattern like sometimes I like to use. So it becomes like Flash because it's the whole thing is like pixelated into 1 pixel. Maybe it's easier to illustrate, like if I do like pixelate 4 4, then you see that they are like divided into 4. OSC is vertically same, so you don't see the variation vertically, but you can see that these like 4 blocks are like separated. But if you do like 1 1, it's like whole texture is like 1 pixel, so it just goes like on and off, on and off. And I use this sometimes to create a mask, for example. And how does it look like? So I have this fractal, and sometimes it goes off, and you can see the feedback goes, or feedback or fractal goes, kicks in like super fast. It may be interesting to explore like this. If you don't like the white color, you can always do color to color it. Do it after luma, because luma will affect the color. So I will do after luma. And for example, if you want to like wipe it black, then it's color 0 0 0, and now it's refreshing once in a while with black color. So this is like a little trick I use. Maybe this is more like advanced tutorial kind of topic, but without this it also works, that it's just like a continuous fractal pattern happening. So if you want to have like variation, it's kind of like useful also if you want to like do VJing, I think. And you can also use the same pattern for this one, for example, right? So I just went to this example above, which I made with this kind of spongy texture. And if I add, okay, it was inside layer, so it has to be here. I add the layer of like black wipeout, then it would make this, once in a while. I don't exactly know what the rate is. You can calculate, but anyways. So there are like little things that you can do, and you can combine maybe with feedback, or you can also always go back to the API page and choose, if you actually want to do saturate or contrast to make this little blocks, little repeating patterns, like some kind of different variation, not just with hue or colorama, but you can do a lot of things with it. So if you create something interesting, please let me know or let us know. You can write down in the comment below, or you can share it with Discord group, Facebook group, or like you can also reach out to me by email or Mastodon. It will be nice to see what you create, and also if you have questions or like wishes, just like this video, I pick it up from a comment. So those I check them as much as possible. So let me know, and I hope you enjoyed this tutorial, and I hope to see you in the next video. I don't know actually what topic I will talk about in the next one, but let's see. So thank you for watching, and happy coding. Bye.